So today the topic is going to be a bit more generic in terms of how an enterprise usually embarks on a journey to AI. And basically, it is a very intriguing topic as we speak. There are many aspirations that people have today about AI in general, and there are some misconceptions, and there are some myths about, let's say, AI that we need to sort of uncover today. And I'm going to give you a point of view how IBM perceives AI to be, and we'll talk about a bit about a history as well, and we'll give you a industry standard definition about what other people are talking about AI as well. Right. So first and foremost, welcome to this session. The way this has been set up is I will not be able to sort of curate the chat, but if you have any questions for me, there is a slot that is going to be kept reserved for question and answers at the end of the session. So I believe we will keep about 10 minutes or so after the session is done with to go through those questions if there are any. All right, so let me start off with giving you a brief introduction about what Gartner has to say about AI in general. I don't know if you know Gartner, but Gartner is an industry analyst who basically does assessment for different vendors. And this is still a dated sort of study that Gartner did. But in 2021, they did a study where they said that this industry will generate about 2.9 trillion in business value and 6.2 billion hours of worker productivity. That's the amount of magnitude we're talking about when it comes to AI and projects and embarking on different initiatives when it comes to AI. Now, if I go slightly back in the past, how we used to do, let's say, some due diligence on our data. There used to be some inputs. There used to be some business rules that we used to design. And based on this, we used to program or hard code these business rules. And then there used to be some output which we used into our decision-making process. Well, in the new era, that has changed. And in the way that AI looks at it is we have made input and output as input parameters to what we call as machine learning. And this term is very broadly used by many people, but in a machine learning model, you need to specify what are the input variables, what is your desired output variable, and then you run various combinations and permutations of algorithms or hypotheses, as I call it. And then you will generate rules out of those hypotheses to take actions on those appropriate for your business. So that's how people perceive machine learning to be today. So that's a very quick introduction to what machine learning is in general today. Now, let's look at some practical applicability of this. So if I go into, let's say, divide it into three capabilities, and I'll talk about capability, then I'll talk about what technology we use behind the scenes, and then what is the input variable and what is the output variable. The most common one that is being used today a lot is listen and speak. So the input or the technology for that is speech to text. And basically that speech is converted into a transcript by a machine learning algorithm by listening in and giving you the output as a transcribed output for the speech that was given as an input to this. So this is one way of applying, let's say, a machine learning model to extract transcripts from speech. The other one is another capability, which is called understand. Usually when people are typing in on websites or they are doing tweets about certain, let's say, topic, they are putting some post on social media, that time it is important for us to understand the context of that language that they are using. So the input in this case is the text that person is typing. And then we sort of decipher from that input what are the different entities or emotions or sentiments that are coming up in that particular specific area. So that's how we understand what needs to be done in order for me to battle this particular objection that came from the customer or from whoever that person is putting that comment. Then we go into interact. And again, this is becoming a very common norm today for any organization. Imagine here in the UAE, we've got RTA, we have got Etisalat, we have got many government organizations who basically are having virtual agents now being set up who respond to you in a flash of a second without you waiting for a physical person to answer your questions. So most of the organizations now, in order for them to not miss an opportunity, they will release these virtual agents on their websites, and they will eventually let customers log in with their website, log in with the user ID and password, and let them interact with these organizations by asking questions and then respond to them automatically by a bot, let's say, instead of you actually having a human agent behind the scenes. So again, I'm giving you different examples here of how machine learning can be applied. Let's go to the next one. This is again a very prominent one, very well used in many industries, and I'm going to give you some examples around where this is being used as well. So computer vision has been one of the most significant, let's say, area in which many industries have benefited. Oil and gas is one of them. Oil and gas companies today use a lot of vision analytics to come up with different kind of analysis that they think. So the input in this case is the image itself, and the output could be a label or a segment or a categorization of a certain element that you want to do. I'll give you some examples on computer vision in a minute. Then it comes to the final one, which is the predict. And in predict, this is again the most used ones. Usually the telecommunication industries or the banking industries use these algorithms to do a prediction of the future, where we are trying to understand, based on behavioral patterns of the customers, how this customer is going to respond to your, let's say, campaigns, to your offers, to whatever. Most of the times, organizations do not have these kind of capabilities, so they started to put up blanket offers and they spray paint these offers. But these days, there are more selective campaigns been run for selected type of customers who will be selected by means of predictive analytics and by learning machine learning to understand who are the low-hanging fruits and who are the people whom we should actually extend our offer to in this case. All these are examples of what we call as machine learning, right? And these are used in different shapes and forms. I have mentioned a few here. There are some other examples as well. And I'm going to cover some examples of how it is actually applied this into practical life. So before Guy going into explaining how the journey to AI actually is released by different individuals and different organizations, I'm going to give you a perspective of what and how these organizations are using these capabilities to render information and give a better experience to their end customers. So let me bring up the first examples for you. This is a very known example of customer care, where if I just take RBS, for example, or in general, any bank or any telecommunication, in order for me to have elegant technology interactions, which have become a key factor in many customer decisions, financial institutions must strive to digitally differentiate themselves from the competition. So many banks have recognized that although its customer service representatives were crucial to a customer journey, they spend too much time handling problems. So the customer satisfaction went down, the wait times negatively impacted their overall satisfaction. And that is where these institutions, like, for example, we have a chatbot from Rashid, we have a chatbot on RTA, we have a chatbot on RBS, and so on and so forth. All these individual organizations embarked on this journey to give a more seamless experience to the end users by significantly reducing the wait times and getting to the questions that they have asked, and get answers quickly. During COVID period, remember, there was all lockdown. There was no human agent, honestly. So people were working from home. There was so many challenges. So chatbots became very prevalent in that era, and it is still going strong. And people do realize the aspect, not just to give a customer satisfaction, but also to reduce the cost that is in keeping and maintaining, hiring these individuals. Now, let's move on to another example where I'm going to talk about Expert Assist. So what is Expert Assist? Most of the organizations do maintain what we call as a hard copy of all their documentation, right? They have a lot of files, they have a lot of project work that they would like to keep. And all these files and project work, if they're not digitized, and even if they are digitized, there's going to be a lot of humongous effort involved in searching for a particular aspect. So in this case, Expert Assist is another area of machine learning and AI, which can help you sort of become a knowledge worker and put knowledge at your fingertips across the company, helping answer tough questions faster and to enable fact-driven decision-making on complex projects. Imagine these companies like Woodside Energy is one example where they were seeing a lot of attrition or a lot of people leaving away from Woodside, and the capital projects that they embarked on basically did not have continuity. And because of this, they approached IBM, and IBM gave them this Expert Assist solution, which helped them combat these capital projects and eventually work on something which is more continually available for them, for their knowledge workers. And likewise, for all the different organizations over here, you see always there is reduction in time, value, and also it is reduction in cost because people are going to spend more time analyzing than searching for data itself. So this was another aspect of machine learning, and it's called Expert Assist or unstructured search. Then we move on to a customer experience kind of area where many times, from the banks in this region, mostly we receive a lot of offers which are irrelevant at times, which don't make sense. We receive offers from airline companies or from retail organizations which are not relevant to me at all, and because of which the customer experience or customer satisfaction level goes down, and they, instead of becoming advocates, they become inclined towards going to buy something else from somewhere else. So in order for us to give a proper customer experience, there is a number of ways you can achieve that by improving the interactions that we are doing with the customers in terms of sending them campaign offers, and also deciding what will be the next best action that needs to be done for this particular customer in general. So this basically increases the number of credit products accepted per customer, which basically results in revenue, which basically results in reduction of cost as well and bottom line overall. This is another area where machine learning is very commonly used, and AI in general has been infused in applications that will help organizations combat these different challenges. Now, this is a very unique area, and why I'm saying unique, because you can imagine a company like Total, for example, is an oil and gas company based out of France. where the drilling operations is a complex and expensive business. Delivering a new well cost millions of dollars. So Total partnered with IBM to build a real-time drilling event prediction solution that provides rapid, accurate insight into operations and help to avoid NPT or non-productive time and minimize the risk of having to abandon the well. So you can imagine these capital projects which run in millions of dollars and over a large period of time, or a longer period of time, they have to be very carefully thought about and taken care of. Otherwise, we will not be able to complete it in time, and therefore it will cost extra money. And there are several examples of operational efficiency that we can cite out. It could be in the healthcare industry, it could be in telecommunications, it could be in oil and gas. Again, another example of AI and machine learning, where we can apply it in real life and come up with, let's say, immediate actions that need to be taken around it. Demand forecasting. So I'm sure everyone in this room goes into any supermarket, right? Like Carrefour or Lulu or Union Cooperative, where if, let's say, a certain item in the shelf isn't available to you, you get frustrated. So you're not going to be able to buy that item at the time because you did not find it in the shelf at all. So in the case of demand forecasting, we help customers align with the intake of the goods that people are going to be buying, and appropriately give them a forecast of how many items that needs to be kept on the shelf at what point in time. So this will basically give them an optimized inventory of goods that needs to be shelved in that area in order for them to have a more satisfied or a more better experience for the customers over. This is again a very important area. It again saves a lot of money to the business and gives them the ability to do a proper planning for their business in the future as well. Okay. Moving on, we have one last example I'm going to talk about is about healthcare. Now, healthcare is very sensitive, right? It's an area which you can't take a chance, basically. You have to make sure that you have the best treatment that you get available in the when you go to and reach to a hospital. There are specialists who are there available to you at your disposal, but that specialist taking the help of vision recognition or image recognition can now improve the accuracy of detection, let's say, of a tumor or of any disease that you have, if you have any diseases. So doctors today in this region and elsewhere as well are most certainly using machine learning and AI to come up with their own hypotheses or their own analysis, let's say, and they're taking help of machine learning to give them a more accurate picture about what the root cause of the problem could be. And IBM has worked very closely with many organizations here in the Middle East as well to give them comfort or give them a solution to give them a better, let's say, analysis of the treatment that should come follow through it. So these are some of the examples. Now, these are not the exhaustive list. There are many more I can talk about, but in the interest of time, I'm just going to cover only these specific areas. Now, if I go back to the same quote that I showed you earlier about Gartner and this 2.9 trillion business in value and so on and so forth, this is all good. But if I look at the reality that Gartner also shows, is that 85% of the AI projects will deliver erroneous outcomes. And there are many reasons behind it. The reasons I'm going to talk about in my next few slides is there. But you have to realize that you have to have an absolute discipline when it comes to AI. And then again, AI is not a myth or a magic. It is something which you need to be diligently following a process through. And I'll show you some mechanisms in which IBM has designed a way to help you embark on this journey of AI and come up with, let's say, meaningful insights eventually for your own data sets. Okay. Now, My following slides are going to be more around, let's say, the offerings within IBM. And I'm going to give you a perspective of what I feel as Ashraf about a organization's landscape. And then we're going to speak purely about what IBM has to offer in this space. All right. So based on my experience that I've done in the past, most of the times, most of the organizations, they have these kind of departments, right? So they have a finance department, a sales department, an operations department, and there could be many more. I could list only 4 or 5 here, but you can list them all on the scale, for example. And these divisions and departments have got business needs, and those business needs are usually because they want to take some corrective actions, or they want to take some informed decisions, let's say, in order for them to either grow their business or sustain their current operations. This is usually categorized into these 4 elements. And those 4 elements are descriptive, which starts with just plain reporting and dashboarding; diagnostic, which is mostly around talking about the why part of the business. So let's say this particular thing happened, why it happened, and the reasoning behind it as well. And then it talks about predictive analytics, which is, all right, this has happened in the past. Can you tell me what will happen in the future? So it goes to some predictive. And then prescriptive analytics is that, okay, I know that there are 4 things that could possibly happen in the future. Out of these 4 things, can you tell me which is the best one for me in terms of saving my cost or improving my operational efficiency? So these are the 4 types of analytics that we can actually work on in an organization today. But it's also dependent upon the methodology that you adopt, right? And that methodology is important. And most of the people fall into one of these 4 categories. So these business users that we're talking about, these are generally going to be people who are going to be, some are going to be just interested in processing their data. So they are interested in collecting data. Some people are responsible, who are owners of this data. They would want to have this data organized in a way that it has been understood by the business across. Some people are business analysts who don't care about these 2 aspects, but they are more interested in taking the finished goods and doing some analysis on top of it by either doing reporting and dashboarding, or doing some analysis in terms of building a machine learning model. And then there are certain areas where they would want to infuse this into an application. So for example, if you have a CRM application, or if you have a call center application, you want to infuse those insights that come from the analyze phase to able to take a better decision at the touch point. So imagine now, if a customer calls up in a call center agent, in your call center, you can take that analysis and understand what is the next best action that you can avoid, that you can apply to this customer once he's available to you over a chat or over a phone. So again, these 4 pillars are important. Keep this in mind. I'm going to talk about this in more detail in my future slides as well. Again, most of the people don't respect the fact that data is important. As they say, data is the new oil. Most of the times you must have heard this concept as well, right? Now, data comes in various shapes and forms, and comes in various speeds as well. So we need to see what data is good for us, is having some signal so that we can use it into a decision-making process. And then as business evolves, these data changes, grows, sometimes it shrinks. There's a lot of variety of data. Sometimes it is in a flat file, sometimes in images, it's structured, unstructured data. All this data is available in an organization, which needs to be harnessed into the entire process. So this is all the scale of a business user, the technology components, or the requirements. But there is also one more aspect, which is skills. And most of the times people don't realize the fact that if they don't employ proper skills within the organization, they will not be able to get the necessary output. And it's not one size fits all. These are some of the known roles that I think are important for you to sustain an operation for AI in general. So I'll give you an example. A data scientist is a good person who understands the machine learning models, and he knows which model to apply when, and he also has a good understanding about the business as well. So now there are industry standard data scientists as well who are propping up in this era, who are experts in, let's say, oil and gas, or in retail, or in telecommunications, and they're giving their experience and their expert advice to the business in order for them to apply those machine learning models and use them at the point of impact. So this is a different personas where you will use these personas and have each one of them has got a distinct role to play in this journey that you're going to take on AI. And then at the last, cloud is becoming very important, right? Your application that you work on today it should have the ability to be deployed on multiple clouds, or private clouds, or hybrid cloud, as you call it these days. Unfortunately, the reality of the matter is that most of the organizations are working in silos. That means they have a hodgepodge of different applications that are available today in their organization, and they are busy integrating those applications. They are busy doing patching work to make sure that the data lands in the right place, it lands in the right hands, and they're trying to cater to their business needs. There is a fat gap still between what the business users demand versus what is actually available and given to them in reality. Now, what does IBM has to offer for this in this area? We have an application of IBM made a strategic investment in machine learning and data science overall. So they said, we will not go with the traditional approach of bringing in all these different applications and trying to patch them together. We are going to give you one application, which is called Cloud Pak for Data. And although the name is Cloud Pak for Data, it is basically a Kubernetes-based or a microservices-based application, which runs all of the data and AI capabilities that I'm going to talk about in my next slide, and brings to bear, or brings all the different personas in this slide listed over here into one environment, so that they can start to collaborate on different aspects of the business and start to get a single view or single version of the truth, as they say, from this particular investment that you have made in this area. So remember this word Cloud Pak for Data, and remember the word microservices, because this is the future of machine learning and AI, and data and AI and overall. All the organizations, whether they like it or not, they will move to cloud. They will have to have some kind of a cloud available in either in country or externally, and most of the applications will be hosted in the cloud in the next 3, 4, 5 years, who knows. Earlier there was lot of resentment, but these days we are getting a lot of acceptance on the cloud itself. Now, what does happen? So let's talk about Cloud Pak for Data. Now, IBM Cloud Pak for Data, as I said, is a ecosystem which houses the features and functionalities that can help you climb the AI ladder. And the AI ladder is about bringing in all your data sets together and coming up with hypotheses, experiments, or projects that help you combat use cases. And in order for me to do that, the first alignment, as I said before, is going to be all these personas that we have spoke about in my previous slide are responsible for certain areas of that specific application. And those are going to be basically helping us in creating an ecosystem. The first portion of this is basically around collecting data. And collecting data is important because we have a traditional approach of building a data warehouse. That is one way of looking at things. The other way of looking at things is to virtualize data as well. So this data virtualization becomes handy in where you are going to run your SQL queries and come up with, let's say, hypotheses, or come up with your own analysis and reports based on that virtualized data. So you're not moving data physically as well. So the first aspect is collect. The second aspect is to organize. And in organize is basically, it helps you to maintain and manage quality of data, and also helps you do what we call as ETL, or extract, transformation, and load, and also helps you get to, let's say, a governed data set, which will be helpful to you to use in other stages as well. Then we talk about the second, which is the analyze. The analyze is basically a lot of things in there. There is visualization, of course, where you want to build some good reports and dashboards. There is experiments, or auto AI, as we call it. There is visual data modeling, or visual modeling for those data scientists who do not prefer to use Python or R. And there is a unique area for IBM called decision optimization, which can be leveraged by different individuals and do what we call as operational efficiency in this area, and so on and so forth. And then the last but not the least is to infuse this into your organization's current applications. And I showed you some examples of doing an enterprise search, which was Expert Assist, AI virtual agents, which was the R-based example I gave you to have a virtual agent, or to manage your risk. We have something as well as called Open Pages. And then we have got financial reporting and financial consolidation to do your financial consolidation overall. So this is the full stack of IBM available to you as core services on one single platform, which is based on Red Hat OpenShift, deployable on any cloud of your own choice. Today, we are open. We do not want a vendor lock-in to be only one IBM public cloud or a specific cloud. We are telling the customers today that if you want to embark on a journey of cloud, then or AI, that does not matter. You need to start thinking from the ground zero level of making sure that you put the right seeds in the first aspect itself, rather than waiting and into the future and coming up with some strategy to do integration. So just to recap, this is a four-step approach, and I'm going to talk about these four steps in general. But just before we go that route, I just want to speak about very briefly about the deployability. And there are many options that we have today of deploying this application called Cloud Pak for Data on either on-premise. Most of the customers who still are not so inclined towards moving towards cloud. So IBM has got an open information architecture for AI, and it is built upon Cloud Pak for Data on Red Hat OpenShift. And it's built for a hybrid cloud world. And it's more flexible, let's say, in terms of an organization, they can place it in a way where they feel more comfortable. So some people are doing a hybrid approach where they have subscription of Microsoft or AWS, and they're putting some of their workloads in those data centers from Massachusetts, and so on and so forth. Now, all this is good. So the technology does exist. I spoke about the technology component called Cloud Pak for Data. The methods of deployments are also clear. And now let's talk about the AI ladder itself. And if I look at implementing, let's say, an AI project, and how does an enterprise embark on an entire project, is IBM has put up a prescribed method or prescriptive method to those people who are embarking on this journey. It is basically all the steps of the journey that an enterprise has to go through to understand how they collect data, how they organize this data, how they analyze it, and ultimately how they infuse it into their core business processes. These four basic steps, there is no shortcut, let's say, to AI. There is no magic that happens behind the scenes. This is how the entire organization will rely on. This is how all the organizations will complete their AI journey, without which missing one step or going and excluding something else may not be so pleasant. You remember the previous Gartner slide where 85% reduces erroneous results is because people don't listen and follow. If you listen and follow these rules of data collection, organization, analyze, and then infusing, you will never fail in an AI project. All right. Now, I spoke about Cloud Pak for data, and I spoke about machine learning and how people are generally embarking on a journey to AI and how it is achieved as well. But one more aspect, or the most important aspect, let's say, is the data itself. And that data needs to be, let's say, persisted in a proper way so that it can be consumed by the downstream applications. And that is the reason why IBM has come up with what we call as a data fabric strategy, where it is helping you to consume data or even persist data regardless of where it is. So the data fabric is one architectural approach that can address the extreme levels of diversity, distribution, scale, complexity, data set types, and adding tremendous complexity to the overall data integration and data management design. So this architectural approach of leveraging data where it says is what we call as an imperative pillar of data fabric. And IBM is working very strongly with this concept because data is so important and because data is affecting every other aspect of the organization. It needs to be taken well care of. So there are many ways in which we can do this, and data fabric is one of the most, let's say, important aspects of machine learning and AI. So by 2023, artificial intelligence in the data fabric will be capable of reducing data quality and mastering ongoing operation cost up to 65%. So imagine now your data fabric solution doing auto-correction of data, which is of bad quality, and reducing the errors that you would otherwise go unnoticed on its own by applying a machine learning logic on top of it. It reduces time for integration as well. By data virtualization, you can have all this data available to you without moving it. So the whichever place that the data is currently persisted, we can keep that data where it is. And the likes of it. So basically, the data strategy or data fabric strategy of IBM has helped many customers in removing a lot of obstacles that they faced in this journey of accomplishing, let's say, an AI. And these two basically go hand in hand, where we have, let's say, a lot of data problems in an organization. And once we resolve those problems, we can safely do all the other machine learning and AI algorithms as we speak. Okay. So what are the cornerstones of data fabric, right? Of Cloud Pak for data in general. And then data fabric is a concept, it's a strategy, and Cloud Pak for data is the actual technology component from IBM, just to distinguish between the two. So the first thing is the governance or the cataloging of data, where you as an organization should be able to book items in a proper way and a common definition across the board, which promotes a common understanding about all the different artifacts that we have today in the organization. So that's something which is called as auto catalog within Cloud Pak for data. The second is auto SQL. Auto SQL is, again, data virtualization, which basically helps you to write queries and on the database where it resides, rather than bringing and pulling data physically inside your platform. You can do data virtualization and write SQL queries to get data from where it resides. Auto privacy, again, this is very important because not everybody has access to everything, especially when it comes to healthcare or or some private organizations where there is data access is something is important. So auto data privacy by masking this data and only showing those individuals appropriate data is also important. And then the last but not the least is doing the experiments on the data itself, which means before I go into actual production mode, I would like to do a hypothesis test on my data to find out if there is any signal and whether should I pursue this or not. So Auto AI was a research that was done by IBM, and based on that research, they released this functionality within Cloud Pak for Data so that they can leverage and optimize optimize the way that the features that have been available to them to be used in the machine learning model, and improve model explainability as well as we go forward in the mix. Right. And this, of course, all coincides to the same AI ladder I spoke about. So it is collect, organize, analyze, and infuse. These are 4 golden words that you should remember. And there is, as I said, there is no shortcut to AI. All of it needs to be done in the same method that I showed you in my previous slides. And then if I come back to a data fabric in action, so what happens in a real organization when you actually go inside into a real organization where you got real data sets and they've got different types of, let's say, existing data that is there available in different shapes and forms again. We have the first thing to do is we start to catalog this data. And depending upon how complex that data set is, we either do a read of the data and try and assign business terms and try and assign policies of access. And based on that, it then starts to catalog it based on what it understood. Again, there's a lot of machine learning involved here as well. Then we speak about quickly onboard new data sets as well. So there is no need for you to add special things. Those new data sets can be added as a new connection inside the platform itself. Automated data privacy, I spoke about already, creates and enforces privacy usages on the data itself. Virtual access, again, don't have to physically move this data inside. You can just directly view it from where it resides. So you don't have to move this data using an ETL process. And then comes to Auto AI, basically using the virtualized access data and giving you access to it directly over there. So this is how the entire cycle works in a real life, where you have different varied type of data sets, and you need to come up with, let's say, some hypothesis or some machine learning algorithm that you would like to use to battle a use case. Now, if I go one step deeper into machine learning itself, these are the 4 steps in Cloud Pak for Data that you would generally take. And those 4 steps are to prepare, build, run, and manage, where each step, most of the times that the data scientists will spend is in preparing the data itself. And why? Because the data that is available to you in your data warehouse may not be conducive to the actual machine learning algorithm that you want to apply. So most of the times, people doing profiling of data to see whether the data is skewed or is there any anomalous data that exists today. And all these are accessed by using the data ops capability within Cloud Pak. And then we start to build what we call as an ML model. The model deployment, development, and the choice of the model will be based on the type of use case we are trying to battle here. And then we try to do model management or model deployment, where we are actually running the model in production. And then we start to take that model and make it, let's say, more accurate based on the findings or based on the output that the model throws to us. So this is an iterative process, and these actions are performed by different personas, as I'm always highlighting. And those personas are basically usually the data scientists or the data engineers, the app developers, and then the business user itself who consumes this data itself. Now, I'm going to quickly go through some of my few slides that are left off because this is important. Now, because I spoke about personas and I spoke about the technology as well, I would like to tie those together and try and align those personas with the capability of, let's say, of a journey to AI process. Okay, so the first persona in this case is in the data engineers, and those data engineers could be managing the data sources either by using an ETL process, or the extract, transformation, and load process, or they could be using data virtualization mechanisms to get this data inside it. So usually they deal with the source data itself, and they transform this data either by using ETL jobs, or they make it available to the individual businesses by means of data virtualization. So that's my first persona. This is called a data engineer. And there are different names given to these people as well. We call it data engineer because he generally deals with data plumbing. Then we've got a data steward, and most often than ever, this persona is ignored, or let's say the discipline of maintaining these artifacts is not there yet. So data stewards are those business users who are very, very important to manage the quality and the governance of the data itself. Imagine there is a term called revenue, and you are from finance and I am from sales. Both of us access this column called revenue, but most of the times I don't understand what revenue is. So basically, I am going to be having a different understanding about revenue versus what you have. So the catalog that the steward creates basically gives them that single definition of a column that is needed for your common understanding itself. So that's your second persona. And then the third persona, which is a data scientist. And now this person could be of two types. One is what we call as a citizen data scientist, who basically can use drag and drop or non-coding techniques to do data science models. So we've got authoring tools for them. And there are those data scientists who basically have an inclination to write Python code. So basically, we are going to use they're going to use open source tools like R and Python to use it in Jupyter notebooks and RStudio to come up with their own analysis. So it's a choice that you make as a data scientist. But this person is the most key person that is going to help you combat your use case, because this person has to have a good understanding about your data as well as a good understanding about your business as well. So this person, a persona amongst the four, I would say, I'm not saying there are not if I grade it by importance, data scientist would be the most important persona, let's say, in this entire area. And there are a lot of jobs open for data scientist roles within organizations who are embarking on a journey to AI or machine learning. The last persona that I spoke about is the MLOps, or the operational guy. Now, the operational guy doesn't care about what model you have. He is mostly doing deployment exercises with whatever has been done by the data scientist and the engineer. He's just making sure that this thing runs in production. So he has got certain responsibilities of making sure that when the model is deployed, it basically lives up to the KPIs that were set by the business. And he also has a dashboard in front of him, which he has to monitor on a regular basis to understand if there is any biasness in data, or also highlight if there is any drift in the data as well, and come up with some better explanation about why this was been done. Now, this is a very important role again, because these days, if a bank, let's say, rejects your loan offer, and you as a customer demands the bank on what basis have they rejected, they have to give you a written explanation about why they did that. They guys can't rely on the machine learning thing. Okay, the machine rejected your loan application. That's it, and it's a black box. No, needs to be a proper explanation. And especially in the Europe, basically, where there is more GDPR rules applied, there is more sort of openness to share this information with your customers as well.